You've probably heard this before. Nothing can go faster than light. It sounds like one of those facts you're supposed to memorize, like a cosmic speed limit sign nailed to the universe. 299,792,458 meters per second. That's it. That's the number. End of story. But here's the thing. No one ever really asks why. Not why like because Einstein said so. Not why like that's just how the universe works. I mean, what is actually stopping you? What's the physical obstacle? Is there a wall? Invisible friction? Does space-time itself put up a nope sign? In everyday life, speed limits are artificial. Cars can go faster. We just don't allow it. Planes could fly lower. We choose not to. Rules, not physics. So if the universe has a speed limit, that means something fundamental is going on. And when you really dig into it, you discover something unsettling. The speed of light is not just a fast thing. It's not a record. It's not impressive. It's structural. It's built into reality itself. And once you understand that, space and time will never look the same again. Let's start simple. Drop your phone. Please don't. It falls. Obviously. Galileo measured it centuries ago. In the first second, something falls about 16 feet. Doesn't matter what it is. Rock, apple, phone, ego, gravity, doesn't care. Now think about the moon. It's not falling. It's just up there, going around the earth, chilling. But here's the weird thing. If the moon weren't moving sideways, it would fall straight down. Crash. End of moon. The only reason it doesn't is because it's moving sideways fast enough that while it falls, it keeps missing Earth. That's what an orbit is. Not floating. Not hovering. Falling and missing. Continuously. Forever. That idea alone is already kind of wild. Now Newton comes along and says, what if gravity weakens with distance? Not linearly, but with the square of the distance. Twice as far, 4 times weaker. 3 times as far, 9 times weaker. 60 times as far, 3,600 times weaker. The moon is about 60 times farther from Earth's center than we are. Newton does the math. If gravity here makes things fall 16 feet in a second, then at the moon's distance it should fall only a tiny amount. And when he calculated it, it matched perfectly. The moon was falling exactly as predicted. 2 completely different things. Apples falling and the moon orbiting suddenly became the same phenomenon. Same rule, same math, same universe. From that one idea, a flood of understanding followed. Planetary orbits, ellipses, tides, why planets are round, why they bulge at the equator, why oceans rise twice a day. One law explained everything. That's how physics works when it's good. Not by adding facts, but by revealing connections. Then came light. People began testing Newton's laws more carefully. Eventually, they found a problem. Jupiter's moons weren't showing up on time. Sometimes early, sometimes late, by minutes. Either Newton was wrong, or something else was going on. Old Rømer had a thought. What if light doesn't arrive instantly? When Jupiter is closer, light arrives sooner. When it's farther, light arrives later. He corrected for that. And suddenly, everything fit again. And just like that, humanity discovered the speed of light. Not by chasing light, but by trusting gravity. And here's why that matters. When a law is real, it doesn't just explain things, it predicts things. It reveals what must exist. Once people knew the speed of light, they noticed something horrifying. Light always moves at the same speed. Always. No matter who measures it. No matter how fast you're moving. You stand still, shine a flashlight, speed of light. You get on a train, shine it forward, still the speed of light. You move at 90% the speed of light, shine it forward, still the speed of light. This should not make sense. In normal life, speeds add. Throw a ball forward on a moving train, it goes faster than if you were standing still. So why doesn't light do this? Why doesn't it stack? Why doesn't it care how fast you're moving? This question broke physics, and the only way to fix it was to break reality. So let's return to the question that broke physics. Why does light always move at the same speed? No matter how fast you are moving, this isn't just weird. It's impossible, at least according to common sense. because in everyday life, speed's at. If you're on a train going 50 miles per hour and you walk forward at 3 miles per hour, you're now moving at 53 miles per hour relative to the ground. No mystery there. So if you're on a spaceship going at half the speed of light and you shine a flashlight forward, the light should move faster than normal. But it doesn't. It still goes at exactly the same speed, which means one of two things must be true. Either all experiments are wrong, or our understanding of space and time is wrong. Einstein chose the second option, and that was brave, because it meant giving up ideas humanity had believed for thousands of years. Before Einstein, everyone assumed time was universal. 1 second for me equals 1 second for you equals 1 second for the universe. And space was fixed. 1 meter for me equals 1 meter for you equals 1 meter everywhere. Distance was distance. Time was time. Simple. But to make the speed of light constant for everyone, those assumptions exploded, because speed equals distance divided by time. If the speed must stay the same, then something else has to change. Either distance changes, or time changes, or both. And the universe chose both. Here's what that means. If you start moving really fast, time slows down for you. Not metaphorically, not psychologically, literally. Your clock ticks slower. Your heartbeat slows. Even your atoms vibrate more slowly. At the same time, distances in the direction you're moving shrink. Not visually, not by illusion. Physically, space compresses. And these effects happen by exactly the right amount to keep the speed of light constant, which is terrifying, because it means the universe is actively reshaping reality just to protect that speed. Light doesn't adjust. Reality does. This is why the speed of light isn't just fast. It's not a property of light. It's a property of space-time. It's a conversion factor between space and time. Space and time are not separate. They are the same thing. They are space-time. Different directions in the same structure. Here's a way to feel it. Right now, you are moving through space-time at a constant speed. Always. You can't stop. Even if you're sitting still, you're moving forward in time. 1 second per second. That's your motion. If you're not moving through space, all your motion is through time. But if you start moving through space, you have to take some of that motion away from time. That means you move through time more slowly. There's a fixed total. You can't exceed it. The faster you move through space, the slower you move through time. This is not metaphor. This is literal. Now imagine pushing this to the extreme. What if you moved through space at the maximum possible rate? You would have no motion left for time. Time would stop. That's what happens at the speed of light. This is why photons don't experience time. From a photon's perspective, it's emitted and absorbed instantly. No before, no after. Zero time passes. And this is also why nothing with mass can reach that speed. To do so, it would have to stop experiencing time, which makes no sense for anything that can change, think, decay, or interact. Only things with zero mass can do that. And yes, people often say you need infinite energy to reach light speed. That's true, but it's not the deeper reason. That's just the symptom. The deeper reason is geometry. Space-time is shaped so that mass resists acceleration more and more as you go faster. The closer you get to light speed, the harder it is to accelerate. Not because your engine is weak, but because space-time pushes back. Harder, 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 until it's impossible. Light doesn't face this problem because it has no mass. It must move at that speed. It doesn't choose. It just is. In reality, the speed of light is the speed of space-time itself, and light just rides it. And it's not just theoretical. Particles and accelerators obey these rules perfectly. GPS satellites need corrections for time dilation, or your phone would misplace you by miles every day. Muons, created in the upper atmosphere, survive longer than they should because time slows down for them. The speed of light as a cosmic limit is as real as gravity pulling you down right now. So now you see the shape of the truth. The speed of light isn't a rule imposed on the universe. It's a natural consequence of how space-time is built. Like angles in a triangle adding to 180 degrees, it just falls out. So far, we've learned something unsettling. The speed of light isn't a speed limit like a speed limit on a road. It's not a rule. It's not a law someone wrote into the universe. It's a structural feature of space-time itself. Now let's push this idea further. What would it actually mean to go faster than light? Not technologically, not emotionally, logically. What would it imply? Most people imagine faster than light travel like this. You just go really fast. Better engine, stronger rocket, more power. But that's not the problem. The problem is time. Once you cross the speed of light, time stops being just slower. It reverses. Here's why. In relativity, different observers don't just disagree about how long things take. They disagree about when things happen. What's simultaneous for you is not simultaneous for someone else moving fast. Now imagine a signal traveling faster than light. There will always be a reference frame where that signal arrives before it was sent. Not metaphorically, literally. Before. Cause-after effect. Reply before message. Explosion before trigger. This isn't philosophy. It's math. If faster-than-light travel were possible, you could build a machine that sends messages into the past. You could warn yourself about mistakes before you make them. You could stop events before their causes. You could create paradoxes with no solution. The universe cannot permit this, so it doesn't. This is why the speed of light isn't just about speed. It's about causality. It's the maximum speed at which cause and effect can propagate. It's the speed of now moving through the universe, the fastest that information can spread, the fastest that influence can travel, the fastest that reality can update. Think about that. There is a maximum update rate for the universe, a cosmic refresh rate, and that rate is the speed of light. Now, here's the part that really messes with people. We say nothing can go faster than light. But the more precise statement is this: nothing can move through space-time in such a way that it outruns causality. Light doesn't break the limit. Light defines it. If light didn't exist, the limit would still exist. It's not about photons. It's about space-time geometry. Light is just the messenger that reveals the structure. In everyday life, you think of space and time as a stage, and stuff moves around on it. But in relativity, space-time is not a passive stage. It's an active structure. It bends, it stretches, it compresses, it defines what is possible. The speed of light is not something happening in space-time. It's something about space-time. This is why nothing with mass can reach it. Having mass means you must experience time. To move at the speed of light, you'd have to stop experiencing time, which is impossible. Only massless things can do that. This is also why you don't feel time dilation. You are always normal to yourself. Your clock always ticks 1 second per second. Your thoughts always feel real time. Relativity doesn't make you feel weird. It makes everyone else see you as weird. And you see them as weird. And everyone is right. The universe is not broken. Your intuition is. Now here's something deeply unsettling. If the speed of light is not just a speed, if it's the structure of space-time, then that means the universe has a built-in notion of how fast reality can happen. Not how fast things move, how fast events can be, how fast change can propagate, how fast existence can update. This suggests something shocking. There is a maximum speed of reality itself, not of objects, of causation, of influence, of becoming, which brings us to the final question. Why is the universe like this? Why does space-time have this structure at all? Why not infinite speed? Why not no limit? Why not instant everything? And here's the frustrating truth. There is no deeper why in the sense people usually mean. There is no reason, only consistency. The speed of light isn't chosen. It's implied. It falls out of the geometry of space-time the way angles fall out of triangles. But this leads to something beautiful, because it means the universe is not a collection of random rules. It is a self-consistent structure, a logical shape, a geometry that can't be otherwise without breaking itself. Let's bring it all together. We started with a simple observation. Things fall. Apples, phones, rocks, they all drop. Galileo measured it. Newton explained it. The moon orbits because it falls sideways, constantly missing Earth. From that, Newton discovered gravity, the invisible force connecting everything. He predicted tides, planetary motion, and even the shape of planets, all from a few simple laws. Then came light. Only Rømer noticed that Jupiter's moon sometimes arrived early and sometimes arrived late. Not a minor discrepancy. Minutes off. Huge mistakes if the universe cared about schedule. Instead of abandoning Newton, he asked a radical question. What if light takes time to travel? He calculated, corrected, predicted, and discovered the speed of light. Suddenly, physics had a new rule, one that defied intuition. Light always moves at the same speed, no matter how fast you are moving, no matter where you measure it. Reality itself had to bend to protect this rule. Enter Einstein. He realized that to keep the speed of light constant for everyone, space and time themselves had to be flexible. Time slows, distances shrink, and space-time stretches, bends, and compresses. The faster you move, the more extreme it becomes. Your motion through time slows to make room for motion through space. The universe enforces the speed limit by reshaping reality itself, not with barriers, not with friction, but with geometry. This explains why nothing with mass can reach the speed of light. As you accelerate, your inertia grows. You resist acceleration more and more. To actually reach light speed, you would need infinite energy. Impossible. Photons, on the other hand, have no mass. They must move at light speed. They ride the geometry of space-time, always on the fastest track reality allows. And it's not just theoretical. We've tested this endlessly. Particles in accelerators obey the rules perfectly. GPS satellites need time dilation corrections, or your phone would misplace you by miles every day. Muons created in the upper atmosphere survive longer than they should because time slows down for them. The speed of light as a cosmic limit is as real and measurable as gravity pulling you down right now. Here's the philosophical part, the part that really blows your mind. The speed of light is not just a number. It is the rate at which reality itself unfolds. It's the ultimate speed of cause and effect. It's the speed at which information, influence, and change can propagate. The universe has a maximum refresh rate. Everything slower is allowed. Nothing faster is possible. And this isn't arbitrary. It isn't a rule imposed by some cosmic dictator. It's a consequence of the structure of space-time itself. Light just happens to travel at that rate because it has no mass. But even if light didn't exist, the limit would remain. So next time you hear someone say, nothing can go faster than light, you can respond, it's not a limit on speed. It's the speed of reality itself. And that's why the universe is stranger and more beautiful than you imagine. From falling apples to orbiting moons to the speed of light to time itself bending, physics isn't just about memorizing numbers. It's about connection. It's about discovering the underlying logic of the cosmos. It's about understanding the shape of reality. That avalanche of discoveries started with Galileo, built through Newton, refined by Rømer, revolutionized by Einstein, and continues today with every experiment, every measurement, every new insight. Physics is not about comfort, not about simplicity. It's about truth. The universe is stranger, deeper, and more logical than we ever imagined. And we can understand it. That's the magic.